Welcome back to this channel for practice problems for actuarial exams. My name is Krzysztof Ostaszewski. You can find information about me at smarturl.it/Jedi. My advice on how to pass actuarial exams is at smarturl.it/pass. The video channel where I post videos with solutions is at smarturl.it/pass actuarial exams. And here you have some information about online seminars that I teach for exams PFM, IFM, and LTAM, and study manuals for those exams that I authored. I direct the actuarial program at Illinois State University. You can find information about it at smarturl.it/actuary, and if you would like to offer a tax-deductible donation to support our students, you can go to smarturl.it/help-ISU-actuary. Here's a problem for today for exam P on probability. Let x1, x2, x3 be a random sample from a discrete distribution with probability function of 1/3 for x equal to 0, so x equal to 0 happens with probability 1/3, 2/3 for x equal to 1, so x equal to 1 happens with probability 2/3, and 0 otherwise, which means that no other value happens. So this is a Bernoulli trial, a random variable, each of those x1, x2, x3. It's a random sample, so they're independent, identically distributed. Determine the moment generating function m of t of y equal to x1, x2 times x3. And here is the solution. Let's write f sub y for the probability function of y equal to x1, x2, x3. And the most important thing to note immediately is that these x1, x2, x3 random variables only assume two values, 1 or 0. If you multiply out 3 of them, then you will get 0 anytime except for when x1 is equal to x2 is equal to x3, and all of them are equal to 1. Otherwise, one of them is 0 and the result is 0, the result of multiplication. So the probability that y is equal to 1 is the probability that x1 is 1 and x2 is 1 and x3 is 1, but these are independent, identically distributed random variables, so the probability of intersection is the product of probabilities of x1 equal to 1, x2 equal to 1, and x3 equal to 1. And each of them has a probability of 2/3 of being 1. Therefore, this product of the probabilities is 2/3 cubed, which is 8/27. And that means that the probability function of y is equal to 8/27 for y equal to 1. So the value of 1 happens with probability 8/27, and then the value of 0 happens with probability of 1 minus that, which is 19/27. So this is the probability function of y. And of course y is therefore a Bernoulli trial random variable with probability of success of 8/27, probability of failure of 19/27, and the moment generating function of it has to be 19/27 times e to the 0 times t, which is just 1, so 19/27 plus 8/27 times e to the 1 times t. 1 is the value that this corresponds to, and of course that's just e to the t. E to the 1 times t is e to the t. And in fact you should easily remember that that's the form of the probability function of of a moment generating function of the Bernoulli trial, that it's equal to q, the probability of failure, plus p, probability of success, times e to the t. And this is answer A. Please remember, this is copyrighted material. The problem itself belongs to a Society of Actuaries. The solution is mine. Good luck in your studies and good luck on the test.